Okay, lovely participants from different countries around the world. Okay, thank you so much for your participation. Let's begin. In today's session, we are going to learn something very practical and beginner friendly. We will see how to create a Google Earth Engine account step by step, how to calculate remote sensing indices, and how to prepare maps from satellite images. Okay, so So here is your mentor, Mohammed Ashikarman Chaudhary, and I'm a GIS and remote sensing analyst. So throughout this session, I will try to explain everything in a very simple way. My goal is that by the end of this class, even if you are completely new to Google Earth Engine, you will still understand the basic workflow clearly. So first, let's start from the very beginning. What is remote sensing? Okay. So remote sensing means collecting information about the Earth's surface from a distance without touching the object directly. For example, when a satellite takes images of the Earth from space, that's remote sensing. When a drone captures images from a small area from the sky, that's also remote sensing. So you can also use this because we normally uses our phone camera to capture any moment, any object. Okay, that's also remote sensing. So in simple words, remote sensing helps us observe land, water, vegetation, urban areas, forest, rivers, and many other things from a distance. For large areas, we usually use satellite images. Okay, this is satellite. This is for large areas. For small areas with very high detail, we can use drone images. This one. Okay. So both technologies collect Earth observation data, but they differ in coverage, resolution, cost, and applications. Okay. Now let's understand GIS. Okay. So GIS means Geographic Information System. It's a system that helps us store, manage, analyze, and visualize location-based data. Remote sensing gives us satellite or drone images, and GIS helps us analyze those images, combine them with other information, and finally prepare useful maps or decisions. For example, remote sensing may give us an imagery of a city. GIS can help us analyze where the built-up areas are increasing, where the vegetation is decreasing, where the water bodies are located, or which areas are suitable for a project. So remote sensing is mainly about collecting Earth observation data, and GIS is mainly about analyzing and mapping location-based data. In real research work, these two are usually used together. Okay. So now, for this type of analysis, we can use different desktop software and cloud platforms. For example, RGS Pro, QGIS, Imagine, and many other desktop-based tools. But today, we will mainly use a cloud platform called Google Earth Engine, or short from GEE, Google Earth Engine. After that, we will also discuss how we can design the final map in RGS Pro. So basically, Google Earth Engine is too much or very much suitable or comfortable to analyze any satellite image. And for map designing, it's obviously RGS Pro. This is a good one. Okay, fine. So now let's start understand another important topic, which is our main topic in this session, in this webinar. Okay, that's called remote sensing index or remote sensing indices. So remote sensing indices are mathematical formulas created by combining different satellite bands, nothing else. So these indices helps us identify specific land features more clearly. For example, from a normal satellite image, it may not always be easy to understand which area has healthy vegetation which area is built up and which area is water. But if we calculate the correct index, the pattern becomes much clearer. Okay. So the most common index is NDVI, normalized difference vegetation index. Okay. It's used to identify vegetation and vegetation health. So where is high vegetation, where is low vegetation. Okay. So we can calculate, we can identify, we can specify with this type of remote sensing indices, which indicates where is vegetation high, where is vegetation low. Okay. So we already told you about remote sensing indices is absolutely a formula, nothing else. So NDVI also has a formula. That formula is near infrared minus red band divided by near infrared plus red band. And question is this: how can we get this type of formula? Simply, we can Google or we can collect from any research article relevant remote sensing indices. Okay, so you can search on Google or you can search on Google Scholar. Okay, then you can find many relevant remote sensing index related paper. Then we can pick one. Then we can pick their formula. Okay, so no need to memorize this type of formula. We can search, we can Google, and we can get easily. Okay, so this type of classification is general classification. So it depends obviously on your project or study area. So don't follow this blindly. Okay, finally, another remote sensing index, another remote sensing index is NDVI, normalized difference built up index, to identify, to detect built up areas like roads, buildings, urban areas, and so on. Okay, so it's mainly used to identify built up areas, urban areas, roads, settlements, and construction zones. Okay, so formula is NDVI equal short wave infrared, SWIR, short wave infrared. Okay, then short wave infrared 1. There are two short wave infrareds normally, 1 or 2. So we use in this formula 1, obviously 1. Short wave infrared 1 minus NIR divided by short wave infrared 1 plus NIR band. This is the NDVI remote sensing index formula. Okay. So when we want to study urban growth, build up expansion, or land development, NDVI can be very helpful. Okay, fine. So another important index is MNDWI. It means modified normalized difference water index. It's used to identify water bodies more clearly. Okay, so the formula is green band minus short wave infrared 1, this is 1, divided by green band short wave infrared plus short wave infrared 1. So this is the formula. And obviously you can get this type of in remote sensing index formula from different remote sensing index based research articles. Okay, GS remote sensing based research article. Simply Google and find this. So no need to memorize. Okay. And one thing is this: you actually need to learn whole process how to calculate remote sensing index. One index properly. You need to learn one index properly because structure or process is similar. If you can do one, you can do anything. Okay, simply change this formula. You need to follow the formula, then follow the process. So this is the easiest way to calculate remote sensing index on Google Earth Engine. So obviously I will try to my best to teach you in a very beginner friendly way and from zero level. Okay, so we will write code from zero, step by step. So don't worry. Obviously we will teach you how to calculate this very easily without writing too much code. Okay. Finally, or later of this training, I will told you how can you do this. But first of all, we need to learn from very beginning, from very zero level. Okay, fine. So now to calculate these indices, we will first create or access our Google Earth Engine account. So requirements is you need to have only one Gmail, active Gmail account. Okay. So Gmail accounts, everybody has Gmail account. So it's pretty normal. Okay, fine. So we will create or access our Google Earth Engine account step by step. Okay, fine. So one thing, before going to the practical, small request, be careful. Throughout the training, if you have any questions, please write them in the Google Meet chat box. We will check the chat after some time and answer your questions. At the very end of the session, we will try to have a question and session if we have extra time. Okay. So during that time, microphone access will be given and you can raise your hand to ask your questions directly. Okay, fine. So the thing is this, if you have any questions, please write them in the Google Meet chat box. Okay. Obviously, we will check the chat after some time or after 30 minutes. Okay, fine. So now let's start. How to create Google Earth Engine account and how to create Google Earth Engine project and how to use this freely. Okay, fine. So I need to share a screen, enter a screen. So just 1 minute. And please inform me, is my audio is clear or screen is clear? So many people from worldwide. Okay, okay. Thank you so much. Thank you so much. Okay, fine. So now I will show you how to create Google Earth Engine account from very beginning. Okay. So we need an active Gmail account, nothing else. Okay. You can create this one freely, completely free. Okay. So now, first of all, here, new Gmail account. Okay, fine. So please write Google Earth Engine. Simply. Okay. So here's the link, googleearthengine.google.com. Okay. So Google Earth Engine, simply click on it. Okay. This is the Google Earth Engine interface. Okay. So this is like one kind of Facebook. Huh? Because we create account or we create profile on Facebook and we log in into Facebook and use this. Okay. So Google Earth Engine is something like that. Okay. So this is not a desktop software. Okay. So Google Earth Engine is the cloud platform to analyze satellite images, different data set. Okay. To solve real world environmental issues. Okay, fine. So now we need to create Google Earth Engine, create account. So simply platform, then code editor. Click on code editor. Okay. So this is the our new pop-up. Okay, fine. So now if we click here, no cloud pods counts. Okay. Why? Because we didn't create one. Simple. Okay, fine. Back. So we need to first of all, we need to click on it. I want to register a new project. Okay, just 1 minute. Okay, actually, I need to change my internet. So I think everything is okay. Okay, fine. So now we need to click, select your country. Okay, then you can select on this. This is optional. You can select on this. Okay, fine. Then click on agree and continue. Okay, fine. Then we need to create a project. Okay, so click on it. Create project. Then simply you can rename this, or you can put this unchanged. Okay, so suppose we can write this project name like uh, no spaces. Okay, no spaces. It can be okay. One thing is this: you can't use this type of underscore. You can use hyphen. Okay, and it cannot be changed later. So this is our project name. Okay, then simply create. Click on create. Okay, fine. So create project already created successfully. Now Google Earth Engine actually now these have both features like commercial, non-commercial. That means paid, non-paid, yeah, free. So we need to create, or we need to register non-commercial purpose or non-commercial use for fully free use. Okay. So then for this, for using fully free, we need to do this must. This one. See if you are eligible for non-commercial use. Don't worry. Simply click on it. Get started. And simply follow me step by step. And you will get fully free Google Earth Engine. Don't. So select your organization tab. You can choose, okay, any of this. So I choose Earth Engine trainee or trainee, trainer or trainee. Then next. Select non-commercial eligibility, pursue role. Okay. So you can choose participant. Fine. Provide the training that it's approximate. Like we can use today's date. Okay. So 2 August 2026. Okay, fine. Provide the end date. That was obviously approximate. You can use like any of this, like December 2027, 31. Okay. So 2027, then December 31. Okay. So this is not mandatory, or this is not fixed. You can use after then or before then. Yes. Then check eligibility. Simply, okay, fine. Based on your answer, you are eligible for non-commercial Earth Engine use. Fine. Then simply click next. So choose your plan. Actually, Google Earth Engine have commercial and non-commercial two options, and they actually provide some free credits, okay, or free limit every month for free use. You can choose community if you do not have any dual currency card. Okay. Or you can choose contributor if you have any dual currency card. Okay. Uh, but don't worry, they actually don't. Okay, fine. So they actually don't need you any or got any payment from you or your dual currency card. It's fully free. Don't worry. But community tier, this is community tier, fully free. This is contributor, fully free. Actually, community tier have less limit monthly, every month, 150 every month. A contributor tier, this is 1,000 limit every month. Okay. So if you have dual currency card without any money, you can choose contributor. Or if you don't have any dual currency card, then simply choose community tier. Okay. So you can change this later. Don't worry. Okay, fine. So then we choose community tier. So we don't need any billing information. If we choose contributor, then we need to enable billing and provide our dual currency card information. Okay. They don't cut any money from you, but we need to put on this. Okay, fine. So simply we can use this community tier, but don't worry. If you limit is over, then simply you can create another Gmail and another Google Earth Engine. Then you can get another 150 limit. This is huge. This is enough, more than enough. Okay. So we select community tier, then next describe your word. This is kind of survey data. So you can choose by own. Okay, fine. You can any one. Okay, that's your choice. Then you can choose will you Earth Engine for any. Okay, fine. Then I can choose agriculture, air quality, AI, ML. Okay, fine. Classroom education, different case. This is one kind of survey. Okay. Then simply okay. Then next. So review summary. Okay, fine. Then simply click on register. Okay. So Earth Engine, this is Earth Engine API, enable API. Okay, fine. Now let's understand one thing. What is the Earth Engine API? This is, I will explain it with a very simple example. Imagine you go to a restaurant. You sit at a table, a waiter comes to you and takes your order. Then the waiter sends your order to the kitchen. The chef prepares the food. After that, the waiter brings the food back to your table. Okay? Restaurant, waiter, kitchen. Fine. Simply, now you are not directly entering the kitchen. You are communicating through the waiter. Okay? So waiter is middleman. Okay? So in this example, the waiter is working like a middleman. So in Google Earth Engine, the Earth Engine API works like that middleman. We write code in the browser. The API sends our instruction to the Google server. The server processes the satellite data and analysis. Then the API brings the result back and shows it in front of us. So Earth Engine API is some kind of restaurant waiter, nothing else. This is the middleman. So obviously, when we want to use Google Earth Engine for analysis purpose, we need to enable this Earth Engine API, this waiter, this middleman. Okay, fine. So we need to click enable. It takes a little more time. Okay, fine. Good. Your project is now registered for non-commercial use. So that means we can use Google Art Engine fully free. Okay. Simply, we need to do how many things? Okay, fine. So actually, we can select on continue. Okay. Welcome to Google Art Engine. Then after that, you need to click on code editor. Okay. Code editor. Okay, fine. So now we are inside the Google Art Engine code editor interface. Okay. So here's the tutorial they provided us. You can check this. Click, click, click. Next. Then this one. Then this one. This one. Then this one. Okay. Done. So fine. This is the Google Art Engine code editor interface. On the left side, we can create and manage scripts. If you want to create another script, what is a script? This is one is a script. Okay, we can write code here. This one is code script. Okay, so we can create new one by selecting script, then new, then file. Then we can, first of all, we can change this type of name. Okay, user, then suppose my name, then okay, then user Ashik, then new repository. Okay, fine. So we can use any name, then create. Okay, then this one is repository, kind of Git. That means version control system like this. Okay, then we need to create file. Create file. Okay, so file name, you can write file name, suppose class 1. Okay, file name. Then simply okay. So click on it. This is our class 1 file. That means code script. Simply click on it. This one, our class 1. No code here, empty. So don't worry. We will begin or we will write from 0. Okay. So on the left side, we can create and manage scripts. So when you will learn so many analysis using Google Art Engine, we will have many code script like this one, this one, this one, this one, this one. Okay, fine. So we can also see docs. That means documents. We'll use this later to write our code. This is a good way to Google Art Engine code writing. Okay, this is documentation. Okay, then assets. Okay, this asset section is very important because this is where we can upload our own shapefile or other geospatial data from our computer, like raster image, tabular data, okay, shapefile, different things. Okay, fine. So this one is code script. This is code editor or code script. Okay, so this is where we write our code. So Google Art Engine mainly uses JavaScript in this code editor, but please don't worry. We do not need to learn complex JavaScript theory for today's session. The interesting thing is that for many practical Google Art Engine analysis, if we understand 4 or 5 core ideas, we can start writing and modifying useful scripts. Okay. So today, because our time is limited, we will not go deeply into JavaScript fundamentals. In our paid trainings programs, we teach Google Art Engine from absolutely zero, step by step, so that even a beginner can confidently learn how to perform analysis. Okay, so good one. So just 1 minute. Prosper Jugo. Yes, we will upload this record class later, after 24 hours to our YouTube channel, and we'll provide this link, WhatsApp group. Hansala, please could you share us the register? What do you mean by register? Please explain kindly. Okay, fine. Actually, I provide a website link. This is our paid training website link. Okay, so you can check it later. Simply copy this. So our beginner friendly batch is going to start on 8 August. Okay, so you can check. Okay, fine. So now let's start our remote sensing indices analysis step by step. Okay, simply. So first of all, we will write code from zero. Okay, fine. So first of all, we need to follow step one. What is step one? Okay, so step one is upload and import the study area shapefile. Okay, so step one is upload and import the study area shapefile. So first of all, we need to load a shapefile of our study area, like USA, Canada, or any state of this country, Sudan, Nigeria, Philippines, Morocco. Okay, different district, different state, different country. Okay, so we need to this type of shapefile or boundary file, okay, of our study area. So you can use different public datasets inside Google Earth Engine, but many times those boundaries may not be updated or may not match your exact research requirements. So the recommended way is to prepare your own shapefile or download from different datasets like ZADM, DivaGIS, SDX, okay, and upload it to Google Earth Engine. So if you don't know where to download from this type of shapefile, was free, so you can search simply like DivaGIS. So this is not updated anymore, but this is a good one to practice. Okay, simply DivaGIS, divagis.org. Okay, simply select country, like you can choose anyone. Bermuda. Okay, fine. So Bermuda. Then subject. If you want to download your country shapefile, okay, then select administrative areas. Then simply click on it. Okay, simply click on it. Close this. Add a zip file will download. Okay, then you can search ZADM. This is another source of download fully free shapefile of any country. ZADM.org. This is not updated. Okay, DivaJS, not too much updated, but practice is good. Okay, then you can download from ZADM. Click on it. Click on data. Click country. Then select your country. Okay, suppose Bulgaria. This is Bulgaria. So we need to download this shapefile. Click on shapefile. Then close the add. One zip file will download. Fine. Another source, SDX. Search on SDX. This one, Union Data Exchange. Click on it. Click on data. Then search your country name like Nigeria or Sri Lanka, Morocco, as you wish. So you can select Nigeria subnational administrative boundaries. You can get this type of shapefile. Okay, suppose click on it. Then we can download this type of shapefile, zip file. Download. Click on it. Okay, so there are so many data, not only shapefile, not only boundary. SDX have so many data. Maximum country, Nigeria flood data, Nigeria food prices, Nigeria health facilities, Nigeria settlements. Okay, so you can find, just click on another page. Okay, so many data you can download. This one is updated SDX. This one is updated, fully free data you can download. Okay, so there are so many sites, so many data sets to download our shapefile. Okay, fine. Okay, so our first step is upload and import the study area shapefile. Okay, fine. So you can download shapefiles from websites like SDX, ZADM, and other reliable sources. After downloading the boundary file, you can use any desktop GS software such as RGS Pro to separate your specific study area. Okay, you can use QGIS too. So for today's demonstration, I have already prepared one study area shapefile. Now I will upload it to Google Earth Engine. And one more thing, if any of you cannot do this shapefile preparation part, please message us on WhatsApp. After the training or tomorrow, we will provide a detailed tutorial showing how to download a country boundary shapefile and separate any study area using RGS Pro. Okay, so don't worry. So now, when uploading a shapefile to Google Earth Engine, we need to click on Asset, then simply New, then simply Shapefile. Okay, fine. So I think this is visible. Okay, this one is visible, I think. So let me check. Just one thing. Okay, fine. So now, when uploading a shapefile to your Google Earth Engine, we need to be careful. Why? Simply one thing. Suppose we have a shapefile like this is a district area or a study area. Okay, so we have a shapefile. So shapefile have so many files, separate different extension .cpg, .dbf, .prj, .sbn, .sbx, different files. One district or one boundary, but so many files. Okay, so shapefile have so many files. Okay, so but when uploading a shapefile to Google Earth Engine, we need to be careful. Why? Because actually Google Earth Engine doesn't allow all of extension. They only allow this type of extension like .ssp, .zip, .dbf, .prj, .ssx, .cpg, so many things. Okay, so try to upload this type of extension file. So see one thing, beginner can mistake. They actually select all of this, but they get error. So try this. Okay, so we will do an intentional error. So we need to select our shapefile. So select source file, then simply find your folder where shapefile is downloaded. Tiny. Okay, fine. So if I select all of this, Control A. If I select all of this file, then select open, we get a message, error message. What is this? They say Feni.sbx does not have a correct extension. Why? They don't allow this. So you need to select those which already have allowed on Google Earth Engine. So .sbx, they didn't allow. They don't allow this. Okay, no SBX. Okay, fine. So simply close, then select, then avoid this SBX. Okay, So we can select Control A, then simply hold on Control key, then select SBX. So this is deselect. We need to select other of this. We can select. Okay, fine. Good one. So if you follow this type of steps, you don't have any. You won't get any error message. Okay, good. So then we need to provide a name. Okay, here this one is your study name or anything else, but try to be unique or try to be short and meaningful. Okay, you will get all the time later, all the time here. Okay, so this study area name is Fanny, so we write here Fanny. Okay, fine. Then this is a small, comparatively a small area, but if you have larger areas shape file like whole Canada, whole USA, whole Brazil, whole Russia, whole Australia, okay, larger shape file. So if you have larger shape file, then you must need to select split large geometries. Otherwise not. Okay, this is a small area. This is average area comparatively. So we don't select this split. But if we have larger shape file, then must be we select this split large geometries. Okay, fine. So simply we can click on upload. So we see this becomes orange color. Okay, fine. Click on it. It takes some time because our shapefile uploading. Okay, so it depends uploading time, but duration depends on your shapefile file size or internet connection. Okay, so simply wait 1 minute. And obviously, once again, if you have any queries, relevant question, please write them in the Google Meet chat box. Okay. Uploading processing. Okay. Process running. Simply wait 1.5 minutes. Okay. So it's uploaded. Upload done. When upload done, it appears tick mark. Okay. Less than 1 minute. This is uploading time. Okay. So already we didn't save if we didn't any shapefile here. So we can click on it or we can click on refresh. Okay. So when uploaded, if you don't see here, you can click on it or you can click on refresh button. Okay, fine. So here is our shapefile. Okay. So this is good one. So successfully we uploaded our shapefile to Google Earth Engine. Okay, fine. So now we need to bring this shapefile into our code script. This is our code script. So here is our shapefile. So obviously, we need to bring this shapefile into our code script here. So simply click on import into script. Okay, click. So by default, Google Earth Engine may give it a name like table. Okay, but for a standard and clean coding style, we will rename it as AOI or ROI. AOI means area of interest. Okay, or you can use ROI as you wish. But be standard, be clean to write this variable name. Okay. So now, from now on, whenever we write AOI, area of interest, in our code, Google Earth Engine will understand that we are talking about our study area. This is called Fanny. We won't write Fanny. We call AOI. We write on our code AOI, area of interest. Okay. So first step done. We uploaded and imported the study area shapefile to our Google Earth Engine. Fine. So you can save your code script by click on save button. Okay. Simply saved. Okay, done. So next, step 2. Step 2. Step 2 is what? This is step 2 is center the map on the study area. Okay. So now our next task is to make sure that when we run the code, our study area appears in the center of the map view. This is map view. So we need to ensure when we run this code, our study area appears in the center of the map view. This is map view, center. Okay. So for this step 2, we will write one simple line. You don't need to memorize. Why? Here is docs. So we can collect or copy from here every time. No need to memorize. Okay, fine. So scroll down. We need map.centerObject. We need map.centerObject. Map center. Simple. Map center. Okay. So click on map. Here it is, map.centerObject. Double click on it. So it gives a short description to you. Okay. You can read anything of this. Okay, fine. So we need to copy this. Okay. So one more thing. This is normal text. Okay. That means this is required. That means mandatory. You need to write this mandatory. But this is italic. This is italic format. Italic font, italic format. So this italic format, this italic font means optional. You can use it or not. Okay. So most of the time we don't use all of this. Simply we use object and zoom. Okay. So object means our study area, that means AOI. Okay. Our zoom means zoom scale. You can use 0 to 24. Any of this. But standard value, we every time use 10. Okay, fine. So we step 2, center the map on the study area. For this, every time we copy this one. We don't need this. We don't need this. Simply two parameters. One is object. What is object? Simply our study area. This is AOI. So copy and paste, comma. Then zoom scale. You can use 0 to 24. So standard value is 10. Standard value is 10. Okay. So map.centerObject, AOI, that is our study area, comma 10. So the 10 is, this is 10. 10 is the zoom level. If we use a smaller number like 5, okay, if 10 is this one, if we use 5, that means smaller number, the map will zoom out and show a larger area. If we use like uh, greater than 10, suppose, so like 50, the map will zoom in and show area in more detail, like this one. Okay, so you can choose a value, standard value 10, and later if you want, you can change zoom out or zoom in as you wish. Okay, so obviously we need to save this one. Okay, fine. So for a district level or upajala level, that means sub-district study area, a value like 10, 9, 11 easily works well. Okay, so try anything. Fine. So you can use after any code line in this Google Earth Engine, actually JavaScript, you can use semicolon. This is not mandatory, but you can use it. Okay, fine. If you don't have this semicolon, code works well. Okay, so this is not mandatory, but as a convention, you can use every end of the code line semicolon. Put a semicolon. Okay, fine. So step 2 done. We need to go through step 3. What is step 3? Create a cloud masking function. Okay, so our step 3 is key. Create a cloud masking function. So fine. So cloud masking function we need to create. Great. But before we create this or we write this cloud masking function, I will show you step 4 first. Okay, we'll do it later. Simply wait. So step 4 is apply scale factors. What is scale factors? Okay, what is scale factors? So this is very important for Landsat collection to level 2 data. So today's demonstration, we will use Landsat satellite. You can use Sentinel or something else. Okay, so but today's demonstration, we will use Landsat collection. So simply search, then browse data catalog. One new page, we will use Landsat satellite that gives us 30-meter resolution. Sentinel that gives us 10-meter resolution, better, higher resolution. This is 30-meter resolution. MODIS, its resolution is like 250, 500, 1 kilo. So resolution is not too much good, but it gives us 1 day or 2 day image. Sentinel on average gives us 5 days image. That means today, then after 5 days. They capture after 5 days, 5 days, 5 days. Okay. So Landsat, in general, it differs, but in general, they capture 16 days interval. That means capture today, then after 16 days, then after 16 days. This works. Okay. So resolution, higher resolution is Sentinel, moderate but medium Landsat, then compared to low MODIS. But these have all different use cases. Okay, so another session or another webinar we will discuss more about it. Okay, fine. So today's demonstration we will use Landsat. So click on Landsat collection. There are so many Landsat satellite, 1 to 9. Active is now Landsat 8 and Landsat 9. These are old satellite, but They provide us previous data, historical data. If you want to analyze historical imagery or historical analysis, long-term trend analysis, so you need to choose this type of Landsat image because they provide us image from 1972 to now. That means 2026, present time. This one, suppose Landsat 9, this is the latest satellite. It provides us 2021 from 2021 to present time. Landsat 8 from 2013 to present time. Okay. Landsat 5, 1984 to 2012. Then blah blah blah. You can check this one data availability. This one data availability. So, if you ask me, how can I identify which is best for me? So I will talk about these things, data availability. If you need like 2000 data, year 2000 data, so you can choose Landsat 5. If you think, suppose 2015 data you need, so you can choose Landsat 8. Okay, or 2026 or 25, you can also Landsat 8 and Landsat 9, two options. So Landsat 9 available 2021 to present, and Landsat 8 2013 to present. Okay, so today's demonstration will use Landsat 8, which have 2013 to present time image. Okay, so fine. This one is good one, so we can use it. Okay. So now we need to select one from these three. Okay. So these data sets, surface reflectance. This is one raw image, not atmospherically corrected. This one surface reflectance, which are already atmospherically corrected and suitable for many remote sensing analysis. That means this is ready to use. Okay, this is ready to use. So exactly these data available from April 2013 to present time. So if your analysis time period between this period, then you can choose surface reflectance. Okay, try to choose surface reflectance because they already atmospherically corrected and suitable, ready to analysis. Okay, fine. Revisit interval 16 days, already told. This is Earth engine snippet. We will use this. Okay. Then this is band step. Obviously, we will use this. Okay. So now, step 3 was step 4 was apply scale factor. Okay. Step 4 was apply a scale factor. So, what is the scale factor? Fine. The value stored inside Landsat images are not always directly stored as final reflectance values. So they are often stored as scaled integer values to save storage and maintain data quality. So before using them for analysis, we need to convert those stored values into meaningful surface reflectance or temperature values. Okay, so you can think of scale factor like a conversion rule. So how can I get these scale factors? Simply scroll down, this one, coded in JavaScript. So they already provided us this scale factor. So no need to memorize, no need to write from beginning. They already provide us. We need to copy this and paste on our code script. Okay. So fine. So for Landsat collection to level 2 surface reflectance bands, we multiply the pixel value by the scale factor and then add the offset. For surface reflectance bands, there is also a separate scale factor and offset. Okay. So the good thing is that we do not need to memorize these values or this code. On the Google Earth Engine dataset page, this one, or USGS documentation, the required scale factor code is usually provided, already provided. We need to copy this function and use it in our script. So simply select Ctrl C, that means copy, then paste. Okay, fine. Google Earth Engine is too much funny. Funny means easy. If you take this like a game, obviously you will enjoy. Don't worry. So I can click on save. So code script will save. Okay. So this is our scale factor. So in today's code, we will apply the scaling factor before calculating remote sensing indices like NDVI, NDBI, MNDWI, or any other remote sensing index. So this will make our index calculation more correct and meaningful. Okay, fine. We will write this step 3 later. So simply follow me. Step 5. What is step 5? Load Landsat 8 image, because we will use Landsat 8 image for this demonstration or webinar. Okay, so Landsat image collection. Okay, so step 5 is load Landsat 8 image collection. Okay, so fine. Simply okay. So in Google Earth Engine, we will search for the Landsat 8 collection 2 level 2. Already we show this one. Okay, you can simply search, click on it, search data catalog, then simply data Landsat. This one. Okay, this one. Then you can choose Landsat 8. Same. Then surface reflex. This is ready to use. Okay, fine. Okay, so same thing. Okay, so good one. We already completed step 4. So fine. So if we want to load Landsat 8 image collection, okay, so we need to create a variable. This thing is easy, but we want to learn this from 0 level. So if you want to learn from step by step, then that's okay. But if you think this is too much complex, I need to customize the code, I need to do analysis simply, easily, then please wait. I will also show how to analyze this remote sensing index or calculate different GS remote sensing analysis based work or task using Google Earth Engine easily by customizing code line. No need to use this type of step-by-step code line from 0 level. Okay, if you think that's work for you, okay, I will also teach you how to customize this. So you don't need to customize this type of code or write this type of code from 0 level. Okay, so please wait. I will also show some kind of shortcut. Okay, so fine, good to see. So if I want to load satellite images, okay, so I need to create a variable. So if I want to create a variable, we need to write this keyword var, short form of variable. Every time if we want to create variable in JavaScript, we need to write var, then a name of variable. Like my name is Ashik, your name is Omar, her name is Alexandra. Okay, so actually is this type of variable, this type of keyword var, using to provide a name, like mine, like you, like her. Okay, fine. So we need to create a variable, like any name you can use. I use image. This is not mandatory. You can use like Alex. You can use like Omar as your own. But we try to use conventional way. Okay. So this is not mandatory, but we use image. That means this is our Landsat 8 image collection. Okay. So this image is our variable name. Landsat 8 variable name. Then we need to assign using equal sign. Fine. The first line, every time loads satellite image, the first line you need to write Earth engine snippet. From here, simply you go to the Landsat 8, scroll. This is Earth engine snippet. Okay, so you need to copy this simply. Then first line, every time first line is this dataset. Okay, fine. So here is our Earth engine snippet of Landsat 8. So we call Landsat 8 whole worldwide data. Okay, so now we don't need worldwide data. We don't need from 1972 to from now. That means 2026. We specifically need 1 year, 1 season, a different use case. Okay, different study area. So we need to filter. When we apply filter, image amount is decreasing, and finally we get the perfect one, suitable one for our analysis. Okay. So second step is that we need to filter. We need to filter this Landsat 8 image using filter date. This is a function to filter our satellite image using date. Suppose there are two portions. Dot filter date. There are two portions. One is start date, comma, then another is end date. So suppose we will analyze for 2020 January 1 to 2020 December 31. Okay, whole 2020. We need to whole 2020. So if we want to 2020, you can write like first of year 2020, then month 01 January, then 1 money day January 1st January 2020. This is our start date. Okay, then comma to end date. So what is our end date? If you want to whole year, collect whole year, you can write 2020 hyphen, then December, whole year December, then day. That means 31, as December have 31 days. Okay. So one thing you need to remember when you use this Google Earth Engine for analysis. Okay. You need to remember one thing simply, that increase 1 day for end date, because Google Earth Engine doesn't include this end date. They calculate 1 day before. This is applicable only for end date, not start date. This is included. They calculate 2020 January 1. They included, but they didn't, but they doesn't included this. Okay. So rule is, if we want to 2020 whole year, if we want to include December 31 also, so we need to increase simply 1 day. That means 1 day after 2020 December 31 means 2021 January 1. Okay, so we don't calculate 2021 January 1 because this is not included one day before. Google Earth Engine only included one day before. So simply for only end date, you need to increase by one day. Okay, fine. Simply save. Then we need to filter more. We need to filter more. Okay. Then we use filter. Okay, first bracket. Then EE dot filter. Then LT. LT means less than. Okay. So what's my doing? Okay. Actually, I want to filter images which have less cloud cover. You know, satellite images have obviously a maximum time cloud related issues. So we need to clean image for calculation, accuracy, better accuracy. We need to remove, we need to get clean image, cloud free. Okay. So if we want to cloud free image, this stage we need to filter according our cloud cover. Okay. So dot filter, EE dot filter dot LT. LT means less than. Okay. So we need to write one thing, then one value. So what is it? Okay. Just follow me one thing. Line set 8. Okay. Image properties. Okay. Then scroll this one. This image properties cloud cover have percentage cloud cover. That means 0 to 100. If we want to filter according cloud cover, we need to copy this one. Then inside quotation paste. Then simply after comma, we need to write a value like 10, 20. So what is this? This filter satellite images 2020 whole year and then filter which have less cloud cover than 10%. Okay. So we try to get less cloud cover satellite image which will provide us better accuracy. Okay, fine. You can increase this like 20, 30 when we need more images. Okay, but standard is 10. Okay, fine. Then another way is filter bounce AOI. What does it mean? Actually, it indicates. It indicates actually Google Earth Engine will only select satellite images, okay, that cover our study area. This dot filter bounds AOI. AOI means our study area of interest. Okay, so this means Google Earth Engine will only select satellite images that cover our study area, not whole world. Okay, fine. Then simply after that, we will apply our cloud masking function. Cloud masking function. What is cloud masking function? Cloud masking function means we use this type of function to remove clouds from satellite image. We didn't remove our cloud here. Actually, we filter out. We filter out those images, those satellite images which have more cloud cover. Okay, so we need to less cloud cover images. Then this stage we will remove those small portion clouds from our satellite image to calculate our different types of analysis for better accuracy. Okay, so we will apply our cloud masking function using dot map. Okay, so using dot map. Okay, dot map. So where is our cloud masking function? Where is our cloud masking function? Okay. So here it is. We need to create from zero, step by step. Okay. So if we want to create cloud masking function from zero, this is the technique how to do this. You can use this type of cloud masking function for different type of satellite, different type of Landsat satellite. Okay. Okay, fine. So now we will calculate in this stage, at this stage, or we will create a function. What function? Cloud masking function to remove satellite image from our satellite image. Okay. So now we will create a function. So if you want to create a function, we need to write function keyword. Then give a name. Okay. Then give a name like cloud mask cloud or anything else. This is a function name. This is function keyword. We need to create a function. So we write function keyword, then function name. This is function name. Then parameter accepted. I will teach you these things, more details. Simply wait. Then second bracket. Okay. So simply space. Okay, fine. If we want to create cloud masking function from zero level, actually we need 4 steps. We need 4 steps. So first of all, step one. One means we need to select. Selecting QA band. QA band means quality assurance band, which have cloud related information. This is first step. Okay. Then we need to select some bit which have directly cloud related information like cloud shadow, snow. Okay. So this one is selecting bit. Okay, or bit flex for cloud shadow to detect cloud or cloud shadow like polygons, snow, etc. There are so many. Okay. Then third step, we need to mask out cloud, then cloud shadow, then snow or others, etc. Step 4, we need to return the clean satellite image. Okay. So total 4 steps if we want to create this type of cloud masking function from zero. Total 4 steps. Okay. First of all, we need to select QA band. So what is QA band? Fine. So we use Landsat 8. So Landsat 8, you need to scroll, select bands, simply scroll, simply this one. QA pixel. This is quality assurance, but quality assurance QA pixel. This is it. Okay. So we need to select QA pixel or QA band. Okay. So this is our QA band named QA pixel. Okay, fine. So first of all, we need to create a variable like QA. Then we need to write image. Image means this image. Okay. Then dot. Then if we want to select a band, we use dot select function. This is dot select function. When we need to select a band, okay, so satellite image band, we must need to use this dot select function in Google Earth Engine. Okay, then this is our QA pixel. This is our QA band, okay, which have cloud related function, cloud related information. Okay, so simply write quotation, then simply QA pixel name, this one. Okay, before between quotation, inside quotation. Okay, fine. Then simple, finish. So done. Step one done. We already selected QA band, which have cloud related information. Step two, we need to select bit of cloud, cloud shadow, snow, etc. So how can we find this? Simply click on bit mask for QA pixel. Okay, so here are so many: deleted cloud, Cirrus, cloud, cloud shadow, snow. So follow this one. Bit 1, deleted cloud. Bit 2, Cirrus. Bit 3, cloud. Bit 4, cloud shadow. Bit 5, snow. If we want to remove deleted cloud, so we need to select bit 1. If we want to remove Cirrus, we need to select bit 2. If we want to remove cloud, we need to select bit 3. If we want to select or remove cloud shadow, we need to select bit 4. If we want to remove snow, then we need to select bit 5. Okay, so most of the case, if we want to get a clean circular image, most of the case you need to select 2. One is cloud, one is cloud. So that means one is 3, one is 4. 3 is cloud, or bit 4 cloud shadow. Okay, most of the time you can use this. Or if you need another, then you can also add bit 5 or bit 2 or bit 1 as you wish. Okay, fine. So step 2, to create cloud masking function from beginning, is selecting bit flex for cloud, cloud shadow, snow, etc. So in this case, we'll use 2. Suppose cloud and cloud shadow. 3, bit 3, bit 4. Okay, so if we selecting bit flex for cloud and cloud shadow, we need to create variable. So every time we create variable, we need to use var keyword. Then simply first we will use, or we will select cloud bit. So name, cloud bit, mask, or anything you can use name. Then simply follow this structure. So what is cloud bit? Cloud bit is 3. Okay, cloud bit is 3. Fine. So every time you use this structure, this one is cloud bit. Okay, every time you use this structure. Then one done, cloud done. So we need to select cloud shadow. So create a variable, cloud shadow bit mask. Okay, or anything else you can put any name. Simply equal, then this format, all time this format. Okay, so what is cloud shadow bit? Cloud shadow bit is a cloud shadow bit 4. So we need to change this 4. Okay, so we already selected our bit flex for cloud and cloud shadow. Okay, fine. Then step 3, mask out cloud and cloud shadow, etc. So we already use 2. So we already mask out only 2. Okay, so for masking out, we need to create another variable, var, then put a name like mask equal. We need to selecting our, first of all, we need to mask out, we need to selecting our QA band. That means which is QA band? QA. Okay, not this one, only use variable, this one. Okay, then use dot, then a by default function like bitwise, and this is the function, by default function, to mask out cloud shadow or anything else. Okay, so QA, this is QA selecting bands dot bitwise and function. Then simply inside bracket we use cloud base mask, first one, copy and paste. Okay, so then dot eq means equal 0. Okay, so actually this one select those pixels which have cloud 0. Which have cloud 0 will provide us clean image. Okay. So then we need to use cloud shadow. So if we want to combine this, we need to combine this. So we need to use dot end function. Dot end, because we need to combine this one. So if we have snow, then we also use another dot end function. Okay. So as we use only two, so we need to one. So first one, this is cloud. Then you need to combine another one, that means cloud shadow. So we need to add dot end function to combine. Okay. So same dot end inside bracket, you need to simply copy this one, then paste. Simply customize this one. Which one? First one is cloud bit. Okay, fine. Then second one is cloud bit mask. Copy this, then paste. We already done step 3. Okay. So easy, super easy. Simply wait. So done. Step 3 done for creating a cloud masking function. You don't have any details tutorial like this, how to create cloud masking function from detail on YouTube or anything else. Okay. So you need to follow this step by step. Okay. Fine. So now step 4. Step 4 is when we create a function, obviously we use return. Okay. A function is like machine. Obviously, all machine have output or return path. So obviously, function should have a return portion or output. So we need to use return keyword. Okay. So to deliver us a clean satellite image. Okay, fine. Then you need to use image, this one, dot. Then we need to use update mask. Update mask. So that they give us this masking data. That means cloud free data. Okay. So inside update mask function, that means inside bracket, we need to use this variable. Finish. Actually, this is our 4-step formula to create a cloud masking function. I know this is a little bit complex for you, but I already told you, if you have this type of function, cloud masking function, you don't need to write from zero every time. For any satellite, satellite means any Landsat, any sorry. So if you use or analyze any Landsat satellite, you can use this code line every time. Okay. So no need to use this, no need to write this from zero every time. If you use Landsat collection or Landsat satellite image. Okay. I will provide you this code. Simply learn how to write this type of code, because fundamentals is mandatory. Okay. If you have foundation, you will create anything. You will customize anything. This is your power. Okay, fine. So this type of code, this step 3, this type code is, this is the function. Okay. How can we identify function? They actually begin with function keyword. So this is a function. Which function? Cloud masking function. Okay. So what is for? This is for removing cloud from satellite image. Okay, fine. So actually we create this function here, but we need to apply this function here using dot map. Okay. So I want to remove our cloud from our satellite image. So we need to create this function before. Then we need to apply this function using dot map. Okay, so simply we need actually this function name. This is function name. Okay, so copy this one, then dot map, inside dot map paste on it. Okay, fine. We already apply how to remove our satellite using cloud masking function. Okay, fine. Simply. Okay, simply, then fine. Then we need to use dot map again to apply this scaling factor. This is also a function. See, this is a function. So here this function we already create or we will copy. So we need to apply. This is function name. This is we want to copy this. Then apply using dot map. Okay. So when we use or apply cloud masking function, we use dot map. When we use apply scaling factor function, so we need to use dot map. Fine. So then we need to suppose within our selected date range, and after filtering cloud percentage less than 10%. Okay, so there may be multiple satellite images within our this date range, and after filtering cloud cover percentage less than 10%, there may be multiple satellite images. But for mapping and index calculation, we usually need one final composite image. Okay, so we will combine all selected images using the dot median function. This time, dot median function. Okay, so the median function helps reduce the effect of cloud, noise, and unusual pixel values. It gives us one stable image from multiple images. Okay, so then last one. Finally, we will clip the image to our study area using dot clip bracket AOI. What is AOI? This is our study area, AOI. This one. Okay, so this means we will only keep the part of the satellite image that falls inside our study area. Okay, we need to save this. Okay, fine. Then step 6. Step 6. Actually, I want to teach you from every detail how to write from the beginning. So it takes little more time. So don't be worried. We will cover all these things. Okay, fine. So step 6 is visualize the true color image. This is our step 6. Okay. So now, before calculating any index, we should first check whether our satellite image looks clean or not. For that, we will visualize the true color image. So you can ask me, what is true color image? So true color means the satellite image will look almost like normal image seen by human eyes, like this one. This one. This one. Okay, so true color means the satellite image will look almost like a normal image seen by human eyes. You can search anything like Africa, Brazil, Ethiopia, Nigeria. This is true color image. This is called true color image. Okay, so fine. Now we need to visualize our study area. Okay. So we need to visualize the true color image. So we need a visualization parameter. How can we find it? No need to write from begin level or zero level. We already have. Here, Landsat 8. Simply scroll down. Then this one. They already provided. You need to copy, then paste. This is our visualization parameter. Okay. So true color means red, then green, then blue band. Serially. True color means first of all red band, then green band, then blue band. Okay. Or short form RGB. So for we use Landsat 8. Okay. So here you can see this is Landsat 8. Select bands red, green, blue. So what is red band? Red band is SRB4. What is green band? This is SRB3. What is blue band? This is SRB2. That means SRB4, SRB3, SRB2. So see, red band, green band, blue band, serially. This is called true band. Okay, fine. It will change when you use another Landsat image like Landsat 5. Okay, so every time you need to check this. What is red band? What is green band? What is blue band serially? Okay, fine. This is our visualization. Okay. Then step 7. So step 7 is simple one quote line. Simple one quote line. Okay. So which actually this is one map.atlayer. How can we get this? This one. Docs, scroll down, map.atlayer. Okay, this one. You can use from here but copy from here, or you can scroll down, copy from this. Both works well. Okay. Okay. This map.atlayer function adds the image, that means satellite image, to the map view. This one is map view. Okay. So if we want to add our map to this map view, obviously we need to write this code line, map.atlayer. You can see here. Every details here. Okay. Simply. So first one is which map? Our satellite image is what? What name? Image. That means we need to copy and paste. We need to show this Landsat 2020 image here. Then we need to copy. Then first one, image name, serial. Obviously maintain serial. This one. Then number 2 portion, second portion, we need to use visualization parameter. This name is visualization, so we paste it. Then number 3, we need to write a layer name, which will appear here. Suppose, okay, keep it simply save. Then run. When you click on run, so here is our study area map. Okay, here is our study area map because we use visualization parameter and also map.atlayer, so that our Landsat 8 2020 image appears here. Okay, so now we need to check 3 things. First, is the image loading properly? Yes, loading properly, full load. Second, is the image clean enough? Clean enough means, is there any cloud or cloud shadow? That means whitish tone or white something? No. Okay. Third, does the image cover full study area? Check, please check. Okay. So here is our study area, and yes. discover full our study area. So you need to check these three questions. Okay, so if everything's okay or if everything looks fine, then we are ready to calculate the remote sensing indices. Okay, fine. Step 8, calculate NDVI. Okay, so calculate NDVI, remote sensing index. Okay, so NDVI means normalized difference vegetation index. We identify where is more trees or vegetation, where is low trees or vegetation, where is no vegetation. Okay, so every remote sensing index has a formula. NDVI also has a formula. So NDVI formula is NIR, near infrared band, minus red band divided by near infrared band plus red band. Okay, so you don't need to memorize. Simply you can Google or you can search on Google Scholar or pick any relevant GS remote sensing based research article, vegetation based research article, and you can find this formula. So no need to memorize. Okay, fine. Then simply we today use only Landsat 8 satellite. Okay, so for our satellite, we need to check what is NIR band in Landsat 8 and what is red band in our Landsat 8. So now check NIR and red for Landsat 8. Simply, this is Landsat 8 page, bands, click. We need to check NIR, near infrared. This is NIR. So this is SRB5. Red, this is SRB4. Okay, fine. So we find here NIR for Landsat 8, NIR means SRB5. Red means SRB4. Okay, fine. Now we need to calculate. Okay, we need to calculate this NDVI, remote sensing index. Okay, simple way we can use multiple time. Okay, fine. So there are many ways, basically two types of ways to calculate formula on Google Earth Engine. One is dot normalized difference, another is dot expression. So now we will use dot expression. Okay, so why? Because this format you can calculate all type of formula. Okay, fine. So another video or tutorial we will share you how to use normalized difference to calculate NDVI, something like that. Okay, so calculating remote sensing index, we need to have basically four things. No need to write from zero level. Okay, simply wait just 1 minute. Just 1 minute. As I want to teach you every detail in today's session, so I need more time or already spent more time. So rest of the class, actually, I will show how to customize. Okay, similar way. Simply wait here. So if we want to calculate any remote sensing index, simply copy this type of code. I will provide it. I will provide it similar way. First one is calculate remote sensing indices. Step one. Step two is visualization parameter. Step three is map.atler to add map this on here. Then final one, most important, export remote sensing index map to Google Drive. These four steps you need to calculate. Okay, that's fine. So first one is this one. This is formula calculation. So we can use like suppose one, no one, this one, step one. Okay, so step one is calculation formula. You can use this every time. So first of all, we need to use variable. We actually calculate NDVI. So name and NDVI equal image. What is image? Image means our satellite image. Which one? This one. Raw satellite image. This is name image. So copy this and paste. Then for calculating formula, we need to use dot expression function. Okay. So there is three portions. One is inside quotation, we need to write our formula. Okay. So what is NDVI formula? This one. So copy this. Then inside bracket, we paste. Okay. NR minus rate divided by NR plus rate. Inside quotation. Okay. Then comma, then second bracket. Inside second bracket, you need to specify what is NR, what is rate. Okay. All unknown things you need to specify inside second bracket. This second bracket. Okay. So left one, you need to select or copy quotation. Inside quotation, NR, then rate. This is unknown. Okay. Then rate. So we need to specify what is NR, what is rate. So our raw image, satellite image is image name. Okay. So copy this, then image dot select. If we want to select a band of satellite image, every time we need to use dot select band. So what is NR band? We already see. NR means for Landsat 8. NR means SRB5. So dot select first bracket quotation SRB5. So NR means for Landsat 8 SRB5. Then rate. Image dot select. Rate means for Landsat 8 SRB4. So inside quotation, write SRB4. Simple. Okay. So finally, we need to rename this. So dot rename. Then here is NDVI. So we can use NDVI. So this is the way to calculate formula. We will use or reuse or how to create another remote sensing indices by customizing this. I will teach you. Simple way. Then we need to calculate step 2. Step 2 is visualization. Okay, visualization. Okay, fine. So visualization, NDVI visualization. So you can name anything like NDVI underscore vis. So don't use blank space. Don't use blank space in your variable name. Use underscore. Okay. Then second bracket. Okay. So when most of the case raw image use this type of bands, but any other images we will use palette, that means color, instead of bands. Okay. So this means this is not minimum and maximum value. This is not like fixed value. Okay. So you keep this same. Don't worry. We will change it on our gear account. I will show you how to calculate this or how to visualize this. This is temporary. Okay. Don't do this. So simply we need to visualization for any remote sensing index calculation or visualization. We need to use palette. Palette means color. So NDVI value range -1 to +1. So value near -1 or less than 0 means most of the case no vegetation. Value suppose greater than 0, some point or 0 point like 0 0.3, 0.354, something else. We indicate moderate level NDVI. Then higher than that, we can use this high NDVI. So high NDVI means high vegetation, high trees. Okay. Or low NDVI means lower vegetation. Or negative NDVI means most of the case no vegetation. Okay. So palette, first one is indicate low NDVI. Low NDVI means suppose no vegetation, suppose negative. So we can use white. White means no vegetation here. Then turn into dark green. Oh, okay. So higher NDVI indicates high vegetation. That means it shows green color. So you use by your own. Okay. So this is not fixed. You can use this. So this one indicates low NDVI or negative NDVI. This one indicates higher NDVI. Okay. So this is our NDVI visualization. Name is NDVI vis. Third number is step 3. Step 3. This one indicates key. Map. Add map to map view. Map view means here. Okay. I want to view it here. Okay. So map.add layer. So map.add layer has 3 portions. First one is which map. I want to add this NDVI. Right? I calculate a formula. Name is NDVI. Copy, then paste. The first portion is which map, which image. Okay. So this is NDVI. Then second portion all time. Second portion maintain serial. Maintain sequence. So second portion is visualization parameter. So name, copy this, paste. Then third number is name a layer name. Layer name shows here. Okay. So write a relevant name. This is NDVI map. So we write NDVI map. Fine. Okay. Then fourth portion. Fourth portion is export. Fourth portion is export map. Okay. Export NDVI map or remove the index map. Okay, fine. So this one export image map or export map. Okay. Sorry. So we can use this template or this code every time. How we can find this? Okay, fine. So docs, here it is export. We need to export image to drive. So we need to use export image. Simply export image to drive. So it will gives us or provide this NDVI map or any other emotional index map or any map to our Google Drive. Okay. So you can copy from here. So many things, but this one is mandatory. Other all italic format, italic font is optional. So we use only those which we must need. Okay. Most of the time you can read this documentation. Okay, fine. Most of the time, actually, you use this template. Simple. No extra things. So we use export image to drive to export our NDVI map to our Google Drive. Which Google Drive? Which Gmail used to create this Google Earth engine? That Gmail has Google Drive. Okay. So you can create a folder on that Gmail account or Google Drive. Okay. Then you can use here. So NDVI map will export on that Google Drive folder. Okay. That's the best way. Okay, fine. So first one is image. Image means which map you want to export. Okay. I want to export this NDVI map. So what's the name? Name is NDVI. So copy this, then paste, then comma. Description. Description means file name. Okay. Every file, every image, every map has file name. So what's your file name? Like NDVI map, inside quotation. Obviously inside quotation, NDVI map. Suppose NDVI map study area, or you can use anything. You can write anything, or but meaningful, short but meaningful. Okay. Third one is folder. Which folder you want to export? Okay. So anything you use. Then region. Region is obviously you use must ay.geometry.bounds. Why? Because this when we export, we analyze, we import any shapefile or something complex shapefile we can use. Okay, so when we export our map from here, it's better to simplify that boundary or that shapefile by using a boundary box. But it doesn't change your raw map because we already use .clip. We already use .clip. Okay, so we will use this to avoid any kind of error to export. So this is a nice print. Okay, fine. Then scale. So how can we use 30? Simply. Lancet 8, bands here. Pixel size 30. If we have like suppose 10, we can scale 10. If we have suppose like 250, we can use 250. So Lancet, most of the case, pixel size 30. So we use scale 30. Then maximum pixel 1e13. That means 10 to the power 13. This is the highest value to avoid pixel related error. Okay, so fine. So all done, completed NDVI calculation, completed an NDVI visualization, completed map.add layer, then completed export map. So now we need to click on run. Simply wait. This on our true color map. This is our NDVI map. Okay, so I already told you that. So minimum, maximum. Okay, so no need to memorize. No need to memorize. Keep that remain same. Simply, every time you run this, you can choose NDVI map gear icon, then custom. Click on custom, then stress 98%. Then changed, value changed. Then simply apply. Okay, so every time you can do this. Though this is actually temporary. We need to visualize, we need to attach color, or we need to classify this type of map in on our desktop JS software. Okay, that's permanent. But this is for visualization, temporary visualization. So no need to worry about this. Okay, fine. So this time I will show you how can you easily calculate remote sensing index easily. No need to write single code from begin level, from zero. Okay, so suppose I will give you this code script. Then suppose you have a different shapefile. Okay, different state area. So you need to click asset, new, then shapefile, then select. Then you can select any other shapefile. Suppose we can use Dhaka shapefile. Okay, so we use this accept.sbx, then open, then select Dhaka or any other name, then simply upload. So this takes 1 or half minute or less than 1 minute. processing or uploading. Actually, now I will show you how to use this code script and calculate remote sensing, any kind of remote sensing index easily. You don't need to write from beginning level. Okay, simply customize this code script. So maximum, most of the student want to do this easy way, shortcut way. They can use this trick, or you can learn from beginner level, which already taught you. So processing, a little bit time needs. This appeared, completed, tick mark. Then we need to click assets, refresh. This one, Dhaka, another shapefile. Okay, so you need to upload this type of shapefile. Then you need to this one delete. Simply hover, delete. Suppose you get this code script, you want to calculate any remote sensing index using it in a shortcut way. Okay, simply you listed here, upload it, then obviously importing the script, change this name AY because we already use AY. Okay, area of interest. Same. Okay, so we don't need to change anything here. Okay, if you want to change your date, suppose I used 2020, you used 2021, then okay. So not all year you can use any season, any summer season, winter season. Okay, so you don't need to take whole year. You can use any season. Simply use your start and date. And date need to increase 1 day. Fine. No need to change. Okay, fine. So now you can run this. If you run this, see, that is your NDVI map. Then in task tab, you can see here your NDVI map. This is unsubmitted, but you need to submit this. So click on run. You can check here, you can check here, you can change from here. Okay. So simply, if everything's okay, then click on run. It will export a NDVI map, this NDVI map to our Google Drive. Okay. So as this type of raster image, this type of map, file size is large, so it takes more time than shapefile. It depends on your file size. It depends on your internet connection. Okay. Okay, fine. So when it exporting, we calculate another shortcut trick. Which one? Simple. We will calculate another remote sensing index, which is called NDBI. Okay. NDBI means normalized difference built-up index. Okay, fine. We can calculate built-up normalized difference built-up index, NDBI. Okay, fine. So if we want to use this code script and calculate any type of remote sensing index, just follow this trick. Simple. You select this export map.add layer, visualization, and calculation formula. Okay. So simply select and copy. Control C. Then paste here. Okay, paste here. Then we will calculate here another remote sensing index using this. Simply customize. What remote sensing index? NDBI. So NDBI formula is short wave infrared 1 minus NIR, near infrared band, divided by short wave infrared 1 plus near infrared band. Okay, so NDBI, which indicates built-up index, roads, urban areas, urban settlements. Okay, Okay, so NDVI, this is the formula. You can get this from relevant research article. Okay, or you can Google it. Okay, fine. So this is the formula. So we use Lancet 8. Okay, so for Lancet 8, we need to check what is for Lancet 8. What is shortwave infrared 1? Then what is NR band? So from where? We need to check from where? We need to check from this code base. Lancet 8. Okay, so scroll down, bands. We need shortwave infrared 1. So scroll down, this one. Shortwave infrared 1. So what's the name of band? SRB6. So copy, then paste. NR band, near infrared. So scroll down, this one, near infrared. So what is the band's name? SRB5. So copy this, then paste. Okay, so this is our formula. This is our NDVI formula, and for Lancet 8, shortwave infrared is SRB6, near infrared is SRB5. So first of all, we need to calculate this NDVI. So we need to copy this formula. Then simply we need to paste inside first bracket. Okay, fine. We need to change variable name. Like this one is NDVI. We need to change it NDBI, built-up index. Then simply unknown variable is SWIR, but shortwave infrared 1. Copy this, then paste. Then copy this, then paste. Okay, so these two is unknown. So we need to specify what is this. What is SWIR1? What is NIR? For Lancet 8. Be careful. So shortwave infrared 1 for Lancet 8 is SRB6. So copy this, then inside quotation, paste. NIR. So for Lancet 8, this is SRB5. So you need to paste inside quotation. Then simply use rename, change this NDBI. Okay. So we can calculate any remote sensing index like this by using customization technique. Okay, fine. Another way to calculate this type of NDBI formula using dot normalized difference. Okay, we will provide another webinar or another session. Okay, on normalized difference. But here, using dot expression, you can calculate any type of formula. Dot normalized difference have some limitation, but dot expression provide you all the power to calculate any formula. Okay, so our formula done, NDBI formula calculation done. Then we need to change visualization. Simply NDBI. Simply change NDBI. This is the visualization parameter. Okay, fine. So built-up index. Normally we use where is no NDBI, no build-up. We use white. Where is higher NDBI. Higher NDBI, like built-up. Where is higher built-up area, higher roads. Normally we use red color, but this is not mandatory. You can use by your choice. Okay, so low NDBI or no built-up index indicates white, and when it turns into higher NDBI, it gets red, light red, dark red, normal red, dark red. This one. Okay, fine. So visualization parameter customized. Then simply we need to customize map.add layer to add map here. Okay. So first one is which map? We need to show this NDVI. So name is NDVI. Need to copy, then paste. First one is which map. Second one is which visualization parameter. We need to copy this, then paste. Then rename this. Suppose this one is NDVI map. So you can change. Then obviously we need to export or design our NDVI map. Okay, or remote sensing index map. So we need to select. Image means which map we need to export. So this one is we need to export actually NDVI. So copy this name, variable name, then paste. No quotation. This is description, that means it's a file name. So NDVI maps, NDVI map, STD, as you wish, you can change it by your own. Folder, you can use, you can change by your own. Region, same. Scale, same. Max bill, same. Simply click run. So here we can see first one is true color. First one is true color. Second one is NDVI. Third one is NDVI. So for NDVI visualization, obviously every time any map you can use this gear icon, then custom, then 98%, then change, then apply. Okay. So dark red means higher NDVI build up. White means no build up. Okay. No build up. Okay. So but this color, this classification, you don't do present it because we will use this type of color visualization symbology change using desktop GS software like ArcGIS Pro. That's a good idea. Okay. This is temporary. Simply visualize this. Okay, fine. So I already told you how to calculate another remote sensing index using this type of code. You can use this. Okay. So now we can calculate another one like MNDWI to detect water body. So simply copy which one? Export map, map.add layer, visualization, then formula. Okay. So copy this, then simply paste. We will calculate here, calculate MNDWI. Okay. Simply paste. Okay. So we need to, what is the formula of MNDWI? Okay. MNDWI means modified normalist difference water index, which gives us, which indicates where is water body, higher water body, where is lower water body or no water body. Okay. So what's the formula? MNDWI formula is like short wave infrared 1 minus. Okay. Short wave infrared 1. Simply one thing, you can Google MNDWI. If you don't have any formula of this, simply MNDWI, Google it. So here it is. Green minus short wave infrared 1. This one is 1, obviously. Divided by green plus short wave infrared 1. Green minus short wave infrared 1. Green plus short wave infrared 1. Okay. So we need to use MNDWI formula. Green minus short wave infrared 1 divided by green band plus short wave infrared 1. So you don't need to memorize this. You can simply Google green minus short wave infrared, green plus short wave infrared. Okay. So this is our MNDWI formula. Okay, fine. So we need to copy this. We need to paste inside bracket formula. So we need to change this like variable name now MNDWI. Okay, relevant sum. So we need to specify this green quotation, inside quotation, short of infrared quotation. So what is green for Landsat 8? So see, Landsat 8 green band. Green band means Landsat 8 SRB3. So copy this. Simply inside quotation paste. Short wave infrared 1. So short wave infrared 1 SRB6. Copy this. Then short wave infrared 1 inside quotation paste. So we already specified what is the green band, what is the short wave infrared 1. Then rename this. This is our band name MNDWI. Okay, relevant one. Same. Then visualization. So visualization, we need to change MNDWI. Visualization, we need to change MNDWI. underscore visualization. Okay, fine. Then we need to change this because water body indicates normally blue color, so we can use blue. That means where lower MNEWI value, that means no water body or low water body, then it indicates whitish or white. Where it's higher MNEWI, that means higher water body, it indicates blue color. Okay, fine. Simply change map.add layer first portion. Which map you want to see here? Okay, so we need to see here MNDWI variable name, copy, then paste. Which visualization parameter? This one. So copy this, then paste. Maintain sequence. Then change this. Okay, simple. Then another one, export map. So we need to change this. So which one? We need to export MDWI, copy, then paste. We need to change file name. Suppose you can use MNDWI. Then you can use your Google Drive name. Okay, region same, scale same, max pixel same. So when we use actually this type of Lancet 8 image to calculate any type of remote sensing index, we can use this. First of all, I already teach you how to write code from zero level. Then I also show you or teach you how to customize and calculate easily. Okay, for better performance. So sorry for this. Actually, takes more time. Committed time duration. Okay. So now, if you have any questions, please write this on Google Meet chat box. I will answer every detailed question. Google Earth using Google Earth Engine and analyzing any satellite image and creating maps is like fun. Okay, so you need to follow a structured pathline, a structured template, a structured guideline from experienced mentor. Okay, so anywhere you can learn, anywhere you can so YouTube channels or any other tutorials or source, but one thing you need to remember, if you have a structured plan, if you have a structured guideline, then you need much more less time. Okay, so very good things or output is possible if you have a structured guideline, but you don't have that one, then it takes long time duration and you feel Google App Engine is too much complex. Okay, so I will provide whole this class record to you and also code script. Then obviously you will practice, you will create Google App Engine, you will practice using this code script and follow my information, follow my instruction, follow my suggestion, follow my advice. Obviously, if you think it's worse for you, okay, I teach you, I taught you very well, then simply inbox us and write a thank you. Okay, so in this stage, if you have any questions, any query, please write this on Google Meet chat box. Okay. So sorry for exceeding expected time duration. Actually, I want to teach you every details from here, step by step, for guided learning. So because though we exceed our expected time duration, we will end this session here, and obviously we will try to organize another live session next week in Saturday. Okay, we'll announce. Obviously, we'll announce. In the meantime, we will provide a tutorial on RGS Pro, how to export Google Earth Engine, and how to download and step by step design this map, NDVA map, remote index map, different map. Okay, so we will. In the meantime, we will provide a tutorial on Google RGS Pro after 24 hours or within 1 or 2 days. Okay, so if you think this session works well or teach you well, then simply write your explanation is your feelings on Google Meet chat box, please. I appreciate your suggestions. So please, if you think this webinar teaches you well, then simply write down your feelings or your feedback, your suggestion. I will appreciate you. So thank you, Evidence K. Mtasa. Thank you, Sama Mirghani. Thank you, Aliyu Inua. Thank you, M. Koshi. Thank you, Azubwek. Thank you, Muhammad Nasser. Okay. Thank you, Saba Mirghani. Thank you, Yusuf. Thank you, Shoaib Khalid. Okay, so we will share the session recording and code scripts in the WhatsApp group within 24 hours. And we also include a step-by-step tutorial on how to export data from Google Earth Engine for map design in ArcGIS Pro and how to map design. And we will try to arrange another webinar uh, next week. We'll announce. So get in touch, WhatsApp group. And if you think this is worthy for you, this is too much beginner friendly, and this is uh, very friendly for you. So you can visit this site. I already provide on Google Meet chat box, and this is our beginner to advanced level training program. Start on 8 August. Okay, so weekly 2 days we'll organize different time slots available because our learners come here from different countries, different time zones. So multiple time slots is available, but weekly 2 days live class. We will start on Google Art Engine with RGS Pro or QGIS. You can choose your one because RGS Pro and QGIS we will use for map designing, and mainly we use analysis portion Google Art Engine, which is the super class. Okay, so in this class, I want to teach you every detail or how can you write from beginner level or zero level. Okay, or if you think no, I don't need this. I only need shortcut way or how to customize, how to analyze anything. Okay, so you are also welcome. So simply, if you want to join with us on 8 August paid training, then simply you can contact through our WhatsApp number. Okay, so here's our website. You can check and you can contact with us anytime. Okay, so thank you so much. Thank you all. Thank you all of you. Morocco, Nigeria, Pakistan. Okay, so Eswatini, different South Sudan, Kenya, Egypt, Burkina Faso, Zimbabwe, Tunisia. Okay, thank you so much. Thank you so much. Thanks all. Okay, just 1 minute. I will provide your WhatsApp group link. Simply just wait. Just 1 minute. Okay, so I already provide WhatsApp group link. If you didn't join here before, you can join. Okay, Saba from Suba Khartoum. Most welcome, Azuget. Okay, so our webinars ends here. So thank you so much. Thank you all. Love from Rejuela.